Good evening, everyone.
Good evening, sir.
Good evening. In the last class, we had done about a few doubts from light chapter.
Yes, sir.
So I think I should be sharing the question paper in the group so that everyone can see and try to solve the question. Right? Like some of you, if you are then anyone else also having any doubts can respond to it and it will also bring about a practice here. Okay, so
Good evening, sir.
yeah, good evening. I'm sharing the
What
question
are we
paper
going
in
to
the
do?
group. Yeah, I have shared the question paper in the group. You people may try to do these questions, and any doubt from that, you can clarify. Today we'll be doing electricity. So I think almost everyone has joined. Let's continue. So in the last class, we had done about the Ohm's law. Okay. So anyone remembers the statement of the Ohm's law? Yes, anyone remembers about this Ohm's law? Okay, Moksha, what was Ohm's law related to? Moksha? Okay, Moksha, you can't turn on your mic. Fine. Ayan? Sorry, Aryan?
Sir, resistance.
Resistance. Okay. And so Ionija, can you describe Ohm's law?
So it states that when the current flows through the wire, uh, the current flow in the conductor, the current increases and the potential difference across the wire also increases.
So basically a similar thing, only we had studied that the current and potential difference, they are directly proportional to each other. So in a current carrying conductor, the current and potential difference, they are directly proportional to each other. That means it states that the current flowing in a conductor is directly proportional to the potential difference. So the current flowing through a conductor is directly proportional to the potential difference, which we call we can relate this as V proportional to I, given the physical conditions remaining the same. So here we had physical conditions that were so according to the Ohm's law, the current flowing through a conductor is directly proportional to the potential difference, provided physical conditions like the dimensions of wire that is length, area of cross section, temperature, and other factors they remain same. So if we plot a graph between V and I, so here we have V, and suppose here we take I. So the graph between V and I is a straight line. So this graph is always a straight line. Now we will resolve this further, that if you find out the slope of the graph, or if you resolve it, you get V equals to IR. So you get V by I equals to R. Got it? So R is resistance, which we also call as the constant of proportionality. So R is the resistance measured in ohm. So whenever if you find out from the graph also, if you find V over I, you'll get the resistance of the conductor, and the resistance of the conductor is measured in ohm. Got it? Anyone having any doubt here? Not today. We'll see the factors on which the resistance of the wire
Sir, can
depends.
you,
Yes, what happened?
sir, once can you again say what are I and R?
I is current. So here
Okay.
I is it is current, and V is potential difference or voltage.
Okay.
So if we consider a simple circuit like this, then consisting of a cell or a battery and a bulb. So the potential difference will be directly proportional to the current flowing here. Got it?
Sir, what are
Yes.
the physical conditions that will remain the same?
Physical conditions, when we say the physical condition, we mean dimensions of the wire, dimensions of wire. That means length, area of cross section, shape. Also, we mean temperature. So these are the physical conditions which we are referring here. Got it? So let's see a few questions from here. Just one. Okay. Here we have few questions. Let's try to solve this question. The values of current I flowing in a given resistance, this one. The values of current I flowing in a given resistance for the corresponding values of potential difference V across the resistor are given below. So I is in amperes, V is in volts. Now, you have to plot a graph between V and I and calculate the resistance of that resistor. So first of all, we will try to plot a graph for this. So you have your V potential and current. Now, as we can see that equal amounts of potential have been taken on the x-axis. So I can take here 0.5, then 1.0, again 1.5. So on you can take this one. Let me take it like this. So this is 0, let's say 0.5, 1, 1.5, 2, 2.5, 3. And you have at last 3.5 and 4. So you have 3.5 here, 4 over here. The current will be taking here on the y-axis. So let's try to take current as in terms of 1 unit each. So we take this one 1, 2, 3, 4, 5, 6, 7, so on. So I think now you can plot a graph. It is 0.5 and 1.6. So it will be somewhere in between this. So this one. Second one is 1.0 and 3.4. So this is 1.0, you take 3.4. The next one. 1.5, you don't have to take up to 2 and 6.7. So at 2, it's 6.7. The next one is, oh sorry, I have taken it somewhere opposite, I think. Just 1 minute. I just need to change the axis. This is your potential, and here you have taken current. This is current I, and here I have potential V. So if I join these two lines, so let's join these points, and you will get almost a straight line. Okay, can anyone tell me what will be the value of resistance?
Three point two.
How much? 3.2.
2.
Okay. Anyone else got the answer?
Sir, I got the same answer.
Okay. See, you can take any value for it. For example, even if you take the last value, that is 13.2, divided by 4. So you're getting 3.3. So your answers which are acceptable here, you can use any of these values. So your answers of R, you'll get as 3.2 or 3.3. So we take the resistance as 3.2 ohm, right? Since during the experiment, there is a negligency, there can be negligency for some accuracy. So we take here resistance as 3. Got it? So we observe that the graph is almost a linear graph. Okay, it's almost a linear graph that we obtain.
Sir,
Yes.
actually I understood how to solve the numericals and how to plot the graph, but then I did not like understand what Ohm's law is. Like, what you're trying to state or prove.
Okay. Ohm's law is not proving anything. It simply states that in a circuit, when some current flows through a circuit, right? So when through a circuit current is flowing, so when will the current flow? The current will flow only when there is a potential difference, right? So Ohm's law states that your potential difference, the amount of potential difference you apply, will be proportional to the current. That means whatever current you get in the circuit, that current will depend on the potential difference applied. This is what the Ohm's law states. So for example, if you increase the voltage, your current will also increase. If you decrease the voltage, your current will also decrease.
Okay, sir.
Got it?
Yes,
Okay.
sir.
So this is what is our Ohm's law. Now, today we'll see the factors on which the resistance of wire depends. The factors on which resistance depends. As we know that resistance is a constant from the Ohm's law, we observe that resistance is a constant for a given wire, provided its physical conditions remain the same. And in the physical conditions, we accounted for area of cross section, length. Okay, all these were the factors. Now, suppose we are keeping everything as same. So how can I vary the resistance? If I want to vary the resistance, so how will I vary the resistance? That means the factors on which the resistance depends. So resistance of any given resistor, suppose I have a resistor here. Let's say this is a resistor of length L and area of cross section A. So resistance will depend on, it depends on length of wire, and resistance also depends on area of cross section. So how does it depend? See, resistance depends directly on the length of the wire, and it depends inversely on the area of cross section. So greater the area of cross section, lesser will be the resistance, and greater the length, greater will be the resistance of the wire. So just these two factors, resistance of wire, it depends on length and area of cross section. So if you increase the length, the resistance also increases. If you decrease the length, resistance also decreases. And it happens inversely with area. So if you increase area, the resistance will decrease. If you decrease area, the resistance will increase. Got it? So if I combine these two, so if I combine these two factors, I get resistance is proportional to length by area. And the constant of proportionality which is introduced here is rho. We call it R equals to rho L by A, where rho represents the resistivity of the material. So rho represents resistivity. Okay, just 1 minute. Wait for just 1 minute. Hello. Just 1 minute, please. Yes, you see, we obtain that resistance is directly proportional to the length and inversely proportional to the area of cross section. So we can say that R equals to rho L by A, where rho is the constant of proportionality, and this constant of proportionality rho is called as resistivity. The resistivity of the material, it depends on, now the resistivity, it depends on material of wire and temperature. So indirectly now I can say that the resistance of wire, if I talk indirectly, so I can say that the resistance of wire, it depends on length of wire, it depends on area of cross section, and resistance of wire, it also depends on temperature, and it depends on the material of wire. Material, which material are you using for making the wire? For example, a wire can be made out of copper, iron, aluminium, silver, gold. So what material are you using for making a wire? That is what resistance depends upon. So resistance, when you are asked what are the factors on which the resistance depends upon, resistance depends upon four factors: length of the wire, area of cross section, temperature, and material. Got it? Where we have included temperature and material as a function of resistivity. Right? So temperature and material, they depend on the resistivity of the object. So you can say that the resistivity of a wire, it is a function of temperature and material. Okay. So by combining all the factors, I will be writing it R equals to rho L by A. Got it? Now, let us see the units. Our resistance R, it is measured in ohm, length is measured in meter, area will be measured in meter squared. So can anyone tell me what will be the units of resistivity? Yeah, what will be the units of resistivity?
Sir, ohm meter.
Ohm meter, right? So units of resistivity will be ohm meter. Resistivity will be measured in ohm meter. Got it? So just by rearranging the terms, I can get it. Let us try to define. Now we need to define 1 ohm, and we'll also define what is resistivity. So let us first start defining what is 1 ohm. So our question is define 1 ohm. So this definition of 1 ohm, we are going to provide from the Ohm's law. So as you know from the Ohm's law, I have V equals to IR, and hence V by I is equal to R. So the resistance of wire will be said to be 1 ohm if 1 ampere current flow through a wire. If 1 ampere current flow through a wire maintained by a potential difference of 1 volt. maintained by a potential difference one volt. Then the resistance of wire is said to be 1 ohm. So the resistance of wire will be said to be 1 ohm if 1 ampere current flow through a wire. If 1 volt, if there is a potential difference of 1 volt. So as we know that potential is directly proportional to current. If you increase potential, the current will also increase. So by this formula, I can get, if I have a potential of 1 and I have a current of 1, so this I will get as the resistance of 1 ohm. So you can also call it 1 volt per ampere. So if there is a potential difference of 1 volt and a current of 1 ampere, we say that the resistance of the wire is 1 ohm. Now let's define the resistivity of the wire. So we have the formula of resistivity R
Sir, can you
equals,
once show the before page?
yeah, sure. Yeah.
Yes, sir.
The next one, we are going to define resistivity. So as we know that resistivity depends upon length and area of cross section. So if the length of wire is 1 unit and area of cross section is 1 meter square, so whatever be the resistance of that wire will be called as resistivity. So we define it like this. We say that resistivity is the resistance of a wire of unit length and unit area of cross section. So if a wire has unit length and unit area of cross section, unit length means the length of wire is 1 meter and its area of cross section is 1 meter square. So you have L equals to 1 meter. You have area also equals to 1 meter square. So then we will have R to be equals to rho. So this is what we justify, that resistance, the same resistance of wire, when we take a specific length and specific area, that resistance would be called as the resistivity of the given material. So the resistivity of the material can be obtained by considering a wire of resistance of length 1 meter and area of cross section 1 meter square. So different materials have different resistivities at different temperatures. But to study resistivity, we just fix a temperature. So we generally talk of resistivity at 20 degrees centigrade. However, we can find it out at any temperature. But for all our practical purposes, the data that we use is the value of resistivity at 20 degrees centigrade. Got it? So everyone has understood to find out the resistivity.
Sir, can you once again explain?
The resistivity, it is the specific resistance of a wire, or you can say the resistance of a wire of unit length and unit area of cross section. That means if I consider a wire, here I consider a wire having length 1 meter. So length of wire is 1 meter and its area of cross section area of cross section A is 1 meter square. So whatever will be its resistance, that resistance will be the same as resistivity. So let's try to solve one question for this resistivity also. See, question number 6. See question number 6, and we try to sort it out by the formula of resistivity. Everyone go through the question. I'm giving you the formula and let's see if you can solve it out. Okay, I expect the answer from all of you. If you're not getting, just expect. So a copper wire has a diameter of 0.5 mm and resistivity 1.6 multiplied 10 to the power minus 8 ohm meter. What will be the length of wire? What will be the length of this wire to make the resistance 10 ohm? So suppose I want a resistance of 10 ohm, then what should be the length of wire? So can anyone tell? We are going to use the formula R is equals to rho L by A. The information which is given over here, we are given the diameter of the cross wire. So diameter D is given as 0.5 millimeter, and we are given the resistivity of the copper wire. So the resistivity is represented by the symbol rho, which is 1.6 multiplied 10 to the power minus 8 ohm meter. So resistivity is given to us, and we want to make a resistance R of 10 ohm. So resistance has to be 10 ohm, and we have to find out the length of the wire. Okay, so obviously we'll be taking the help of this formula. R is equals to rho L by A. R is given to us, rho is also given to us. We need to find L. So length will be equal to resistance multiplied by area divided by resistivity will be equal to the length of wire. Okay. But one thing we need to see here, we are just given the diameter of the wire. So once we are given the diameter of the wire, we can find its radius and then we can find out area also. But we have to find this in meters square. Okay. So let's say first we have the diameter. It can be written, it is 0.5 millimeter. So this 0.5 millimeter can be written as 5 multiplied with 10 to the power minus 4 meter. Am I correct? See, for milli, it is 10 to the power minus 3. For milli, it's 10 to the power minus 3. And it's already 0.5. So shifting 1 point of decimal from here makes it 5 multiplied 10 to the power minus 4 meter. Anyone having any doubt here in finding the diameter?
Oh, sir.
No. So now we can obtain the radius. The radius of the given wire would be 5 over 2, that is 2.5. You have 2.5 multiplied 10 to the power minus 4 meter as the radius of the wire. So now the area of the wire, since the cross-section area of the wire is a circle, so you can find area by the formula pi r squared. Okay. So area of the wire will be given as pi, which is 3.14, multiply radius, that's 2.5 multiplied 10 to the power minus 4 whole square. If you solve it out, you get 3.14 multiply 6.25 multiply 10 to the power minus 8. Got it?
Yes.
Okay. So we'll put this value of area over here. We already have the value of resistance we have resistivity, then we can find the length. Okay. So just putting the values here, we have the resistance R as 10. So we put 10 multiply with area, that is 6.25 multiply 3.14. So 6.25 multiply 3.14 multiply 10 to the power minus 8 divided by resistivity, which is given 1.6 multiply 10 to the power minus 8. So 10 to the power minus 8, 10 to the power minus 8 cancel. And now you can perform these simple calculations to obtain the length of the wire. Okay. Is this clear to everyone? I just gave one more question so that you can do it, you can practice that. Right. So here I'm adding one more question, you can practice that. Already its solution is given in NCERT. Okay. You need to try this 12.5. It's already a solved problem. I'm adding it here. Got it? Okay. So you can either take a screenshot or it will be available on the WeXL. Okay. Okay. Bye all of you. See you again in next class. Hope everyone understood this topic.
Yes, sir.
Yes, sir. Thank you, sir. Bye,
Okay.
sir.
Okay. Bye.
Bye, sir.